You know that feeling, right?
Mm.
You're absolutely dialed in on something complex, maybe prepping for a big meeting or, I don't know, wrestling with a really tough problem, and then boom, you just hit the wall.
Yeah, the brain just shuts down.
Exactly. Your focus evaporates. Researchers call it mental fatigue, or MF. And, well, we all feel it, but imagine you're a pro athlete. In those high-stakes moments, it's not just annoying. It can literally ruin your performance.
Absolutely catastrophic.
So our deep dive today, it's looking at something almost, well, surprisingly simple to fight that cognitive drain. We're talking about athletes looking at nature pictures.
Seriously,
Like,
it sounds simple, but the science behind it is quite compelling.
And we're diving into that science to figure out the precise dose. How much nature do you actually need to look at to reset your brain?
Okay, so the core source we're digging into today is a really solid piece of work. It's a randomized controlled trial published in the Journal of Sports Science and Medicine. That was just this year, 2024.
Got it.
The full title is The Restorative Effects of Nature Exposure on the Self-Regulation Resources in Mentally Fatigued Soccer Players. And the authors are Hee-sun, Kim Geok So, Alireza Mohammadi, Zakaria Toumi, Runzhen Chang, and Jiang.
Okay, quite a team.
Yes, and they tackled a really critical question for anyone interested in performance, not just if looking at, say, a forest scene helps you recover, but specifically how long you need to do it.
Right. How long for it to actually reset that crucial ability you need under pressure,
Yeah,
which they call self-regulation.
precisely.
Self-regulation.
Okay, let's unpack that concept first.
Yeah.
Self-regulation, SR. In soccer, what does that actually mean on the field? It's not just like keeping your cool when you get fouled, is it?
No, it's much broader than that. Think of it as the ability to constantly adaptively adjust both your body's response, your physiology, and your mental state, your psychology. You need to match the demands of the moment. It's really about peak mental functioning.
Okay.
So it's the difference between, say, making a rash impulsive pass versus a calculated perfect one, especially late in the game, right, when the pressure's really on.
Exactly. Imagine a player getting a really tough pass in the 90th minute. Good self-regulation means they can filter out the noise, the crowd, the anxiety, maybe even internal doubts, and focus entirely on the task at hand, precise ball control.
And if that SR fails,
Their focus just shatters. They make mistakes.
I see. Okay, so there's a model that explains why it shatters, right?
Yeah.
The self-regulation strength model. Can you break that down for us? You mentioned it's like a battery.
That's a great analogy. Think of it exactly like a limited cognitive battery. This strength model basically says that all the complex things your brain does voluntarily, paying attention, staying focused, making decisions, controlling impulses, they all draw power from the same single finite resource pool.
Okay, one pool for everything.
One pool. So when you're playing a match, maintaining that intense strategic awareness, anticipating plays, making split-second decisions, you're constantly draining that battery. So prolonged cognitive effort, like in a long match or even a tough training session, it directly leads to mental fatigue. Why? Because that resource pool, that battery is running low or it's empty.
So if the player's mental battery is dead, their directed attention fails. Is that the idea? They can't consciously choose what to focus on anymore.
That's exactly it. Their brain kind of defaults. It starts getting snagged by random external stuff, the crowd noise you mentioned, maybe visual clutter on the sidelines or internal noise like worry or anxiety about the score.
And the mental energy they needed for that crucial pass is just gone, diverted elsewhere.
Precisely. And that depleted state is what the researchers needed to replicate in the lab for this study.
How do they manage that? How do you reliably make people mentally exhausted?
They used a standard method, but it's known to be pretty intense. It's a computerized Stroop task, and they had the participants do it for a full 45 minutes.
The Stroop task. I've heard of that. That's the one designed to be deliberately frustrating, isn't it?
Yeah.
Where the word RED is printed in blue ink.
Exactly. It forces a conflict. You see the word RED, but it's printed in, say, blue ink. Your instruction is to ignore the meaning of the word and just name the ink color blue.
Which feels really unnatural.
It does. It forces you to constantly inhibit your automatic response reading the word for 45 straight minutes. It requires intense, sustained mental effort, and, well, it rapidly drains that resource pool we talked about.
Okay, so it definitely makes them tired. Did they check?
Oh, yes. They confirmed it using something called the Visual Analog Scale, the VAS. It's essentially a structured way for participants to rate how mentally exhausted they felt. And yeah, the 45-minute Stroop task successfully induced a high level of mental fatigue in everyone.
All right, so phase 1 complete. Participants are mentally fried. Now, phase 2, the fix.
Yeah.
How do we recharge that battery? This brings us to the attention restoration theory, RT.
Yes, RT. This is really the theoretical backbone of the study.
So why does art suggest that looking at a picture of a forest, say, is better for recovery than, I don't know, scrolling through Instagram or watching an action movie? Those seem relaxing, too.
That's the key difference RT highlights. It argues that directed attention, the specific type of attention that gets depleted by the Stroop task or making complex decisions under pressure, is recharged best by interacting with nature.
Okay.
But it's the type of attention nature commands that matters. It's different from the focus needed for social media or even a movie.
So it's not just about passively chilling out.
It's actually something more active but effortless. They call it soft fascination.
Soft fascination.
Okay, what's that? Think about looking at clouds drifting by or leaves rustling in the wind, maybe watching waves on a beach or a flickering campfire. These kinds of natural scenes attract your attention involuntarily.
So you don't have to try to focus on them.
Exactly. Your mind just engages effortlessly without needing to actively screen out distractions or exert effort. And that process allows the other system, the effortful, resource-draining directed attention, the one you use for work, or the Stroop task to completely rest and regenerate.
That makes total sense. It's like my brain gets the stimulation that sort of craves, but without the work, without spending energy filtering things out. Rest through effortless engagement.
Yeah, precisely. And it's not just in your head, not just psychological. This nature exposure also triggers a pretty rapid physiological reset.
Okay, how so?
It actually induces a shift towards the parasympathetic nervous system. That's the rest and digest state, the opposite of fight or flight.
Right.
And this physiological shift is directly linked to stress recovery and, critically for this study, to an enhanced capacity for self-regulation. You recover your ability to manage yourself.
So the study actually measured both things. The psychological side, like feeling less anxious, and the physiological side, the body shifting into rest mode.
Correct. They needed evidence for both aspects of restoration. For the physiological part, they looked at heart rate variability, or HRV.
Okay, HRV, I hear that term a lot with wearables and stuff. What specific part of HRV were they looking at? You mentioned an LFHF ratio.
Yes, the LFHF ratio. It sounds technical, I know.
Yeah, but break that down for us. Is there an analogy?
Definitely. Think of your autonomic nervous system, the automatic part, as having two main branches. You've got the gas pedal, which is a sympathetic system driving the fight or flight response.
Yeah.
And you've got the brake, the parasympathetic system, managing rest and digest.
Gas and brake. Got it.
The LFHF ratio is basically a measure of the balance between those two. When you're stressed, mentally fatigued, under pressure, the gas pedal is dominant and that ratio is high.
Makes sense.
But when you start to recover, relax, restore, the brake becomes more dominant and the ratio goes down.
Yeah.
So a lower LFHF ratio is essentially scientific proof that your body is shifting towards recovery. It shows increased parasympathetic activity.
Okay, that's a brilliant explanation. Lower ratio means more brake, more recovery, better potential for self-regulation.
Exactly. Actual physical recovery.
Fantastic. So we've got the mentally exhausted soccer players. We've got the theory RT saying nature helps. And we've got the measures HRV and anxiety. Now, for the really cool part, they tested the dosage, right? Like medicine.
They did. It was quite elegant. They took 90 male university soccer players. Remember, all of them had just done that draining 45-minute Stroop task.
Right, all equally fatigued.
Then they were randomly assigned to one of 6 groups. 3 were the experimental groups. They viewed virtual nature scenes. The other 3 were control groups. They viewed neutral urban scenes like city streets, buildings, maybe industrial areas.
And they saw these for the same amount of time as the nature groups.
Yes, that's crucial for comparison.
And the key difference, the variable they manipulated, was how long they looked at the pictures. What were the durations they tested?
They wanted to find the minimum effective dose, so they tested 3 different lengths. Group 1 got a really short exposure, just 4.17 minutes.
Okay, very brief.
Group 2 got an intermediate duration, 8.33 minutes. And Group 3 got the longest time, 12.50 minutes.
12.5 minutes, okay. And each of these had a matching control group looking at city pictures for the same amount of time.
Correct. A 4.17 nature group versus a 4.17 urban group, and so on.
And they measured the outcome, the self-regulation recovery, using the HRV metric we just talked about.
Yes, the physiological measure.
And also a psychological measure, the CSAI-2.
That's right, the Competitive State Anxiety Inventory, version 2. It's a standard tool in sports psychology.
What does that tell us?
It's useful because it breaks down anxiety during competition, or in this case, post-task. It looks at two things mainly. Cognitive anxiety, that's the mental stuff, the worry, the negative thoughts, the self-doubt,
Mm-hmm.
and somatic anxiety. That's the physical side of anxiety, the butterflies, the tense muscles, maybe a racing heart. The CSAI-2 also measures their state confidence.
Okay, so better recovery would mean less cognitive and somatic anxiety and more confidence.
Exactly. That would show the mental resources were being effectively restored.
All right, the moment of truth.
Mm-hmm.
After all that setup, what did they find? Did staring at like a digital forest actually help these mentally exhausted soccer players get their focus back? Did it calm them down?
Yes, it did. But, and this is the crucial finding, the duration was absolutely key. Ah, okay. So which group saw the benefit?
Only experimental group 3. The players who looked at nature scenes for the full 12.50 minutes. They showed significant, meaningful improvements across all the measures, both physiological and psychological, compared to the control group that looked at urban scenes for that same 12.5 minutes.
Wow. Only the longest group. So the shorter breaks, the 4-minute one and the 8-minute one, they didn't really do much. Basically no better than looking at a picture of a building.
Well, when compared directly to their corresponding urban control groups, the differences weren't statistically significant. Now, they did see some slight improvements in those shorter groups compared to how they felt before the break, so maybe a tiny effect. But it wasn't strong enough or consistent enough to be reliably different from just looking at a neutral city scene, especially given how fatigued they were from that really long Stroop task.
So the takeaway is, for this level of significant mental drain, you need a sufficient dose of nature exposure to really counteract it. 4 minutes isn't enough. 8 minutes isn't enough. In this study, yes, the threshold seemed to be crossed at that 12.50-minute mark.
Let's focus on that winning group then, the 12.5-minute one. How big was the recovery effect? Was it just barely measurable, or was it substantial?
No, the results were pretty robust. Physiologically, looking at their HRV, the improvement was statistically significant. The p-value was 0.008, which is strong evidence.
Okay.
But maybe more importantly for practical terms, the effect size was large. They reported a Cohen's d of 0.93.
And a large effect size, that means it's not just noise in the data, right? It signals a really meaningful real-world difference, a strong shift back towards that brake system, the recovery state.
Absolutely. It's a very solid finding. And they saw the same pattern on the psychological side with the CSAI-2 results.
How so?
Significant improvements there, too. Specifically, reduced cognitive anxiety, so fewer negative, worrying thoughts. Also reduced somatic anxiety, less physical tension and jitters. And, importantly, a significant increase in their state confidence.
So it confirms the mental battery really did get recharged.
Yes, the evidence points strongly towards the 12.50-minute period being the minimum time needed in this context to get that full, multifaceted restoration of self-regulation resources.
That is incredibly practical information, like a concrete number, 12.5 minutes. The implication for coaches, for athletes, even for, students or anyone facing mental drain seems pretty profound.
It really is.
It suggests this nature exposure, even just looking at pictures, helps rebuild that core mental resource pool, the directed attention. And that allows the person, the athlete, to get back control over their internal state, manage the stress, quiet the anxiety, and also block out the external distractions more effectively. It strengthens their focus for complex tasks.
You've got it. It's like rebuilding a cognitive shield, allowing for better concentration and decision-making when it matters most.
Yeah.
So this deep dive, I think it really confirms that nature exposure, even virtual nature, isn't just, pleasant. It's a specific, potentially powerful intervention. And importantly, it gives a practical starting point, that 12.50 minutes.
A benchmark.
Yes, a benchmark duration that coaches and athletes could potentially integrate, maybe during halftime. Or on a recovery day between intense sessions to combat that accumulated mental fatigue.
Okay, but like with any study, we need to be careful about the context, right? The limitations.
Absolutely. The authors themselves point these out. Firstly, all the participants were male university soccer players.
Right, so we can't automatically assume these exact findings, especially the 12.5-minute timing, would apply perfectly to, say, female athletes or athletes in different sports or different age groups. There could be differences in stress response and recovery.
Correct. Generalizability needs further research. And probably the biggest point is the nature of the fatigue itself.
You mean because it was lab-induced?
Exactly. They used that intense but somewhat artificial 45-minute Stroop task. While it definitely taxes cognitive control and sustained attention skills crucial in soccer, it's not the same as the combined physical and mental exhaustion built up over a full, high-pressure 90-minute match.
Yeah, the real world is messier. Which leads to a really interesting question for you, the listener, to think about. If 45 minutes of a demanding cognitive task needs a 12.5-minute nature reset, what duration might a player need after the massive physical and mental load of a 90-minute championship final? Would 12.5 minutes still be enough? Or would they need longer? That real-world application is still an open question.
It's a critical next step. And if you found these details interesting and maybe you want to really dig into the specifics, the exact experimental setup, the statistical methods they used, how they calculated that LFHF ratio, we definitely encourage you to read the full paper.
Yeah, the original source.
It's by Sun and colleagues in the Journal of Sports Science and Medicine, Volume 23 from 2024.
Definitely worth the read if you're into performance science.
Okay.
And hey, if you found this deep dive valuable, please make sure you follow our channel.
And turn on those notifications.
That way, you won't miss our next exploration into the science behind performance, learning, and maybe even more ways to keep your brain sharp. We look forward to diving in with you again.